On October 9, 1997, observers from the Point Reyes Bird Observatory witnessed a killer whale clashing with a great white shark near Farallon Island, 26 miles off the coast of San Francisco. The sight made for salacious nature news. Speculation about what would happen if these apex predators met has always piqued curiosity, but until that day, no one really knew for sure. Someone on the ship caught the confrontation on video, which later made its way onto the internet and became an instant draw for millions of eyeballs worldwide. Turns out it wasn't much of a fight. The orca had little trouble dispatching her menacing opponent, and then proceeded to dine on its liver, leaving the carcass for seagulls to pick clean. This outcome may have disappointed many who expected a bloody jaw-to-jaw battle between these titans of the deep, but it tickled the fancy of academics to the point of giddiness. The reason for their interest had to do with why the two clashed in the first place and exactly how the orca defeated the shark. Ordinarily, apex predators are happy to avoid each other, for the simple reason that fighting a beast in your weight and ferocity class will probably result in injury. Injury means impaired ability to hunt, and that means game over. Knowing this, scientists were eager to know why two of the most successful predators on the planet would risk confrontation in the open seas. The answer shocked everyone. This was no chance street brawl. The orca was actually hunting the shark. To understand why, we have to take a step back to examine how killer whales learn their namesake trade. Like humans, orcas have culture. But unlike most human cultures, orca cultures revolve around one thing: hunting behavior. Some orcas hunt herring, others seal, others stingrays, and others sharks. The observers on the ship had witnessed an orca conducting the business of its shark hunting culture. The next discovery was how the orca so handily defeated the shark. In every orca culture, a hunting technique is learned through demonstration and imitation. That's a big part of what makes orcas such efficient predators. They learn the best tried-and-true hunting techniques from each other. When one orca tries a killing method that works well, others take notice and copy it. Scientists speculate that at some point, an orca discovered that if it rammed a shark hard enough from the side, the shark would flip over and become motionless, unable to defend itself and inflict injury. In effect, that pioneering orca induced tonic immobility in its adversary, a temporary state of paralysis many species of sharks fall into when turned on their backs. The human discovery of tonic immobility in sharks is relatively recent, making the orca's behavior all the more remarkable. This deadly shark hunting technique, capable of rendering a great white shark powerless, is the orca equivalent of a human meme, a unit of cultural ideas and practices transmitted from one mind to another. Susan Blackmore, author of The Meme Machine, puts a finer point on it by defining a meme simply as that which is imitated. The biological corollary to a meme is, of course, a gene, a unit of heredity transmitted from one organism to its offspring. Killer whales are, as a matter of heredity, powerful hunters, but we now know that their cultures strongly influence how they use their native abilities. An orca from a herring hunting culture is not likely to tackle a great white shark, just as an orca from a whale hunting culture would have no reason to start hunting stingrays. The key point is that orca cultures pass along memes that benefit their members via learning and perfecting crucial skills necessary for survival. The orca brain is advanced enough to make this meme transfer effective beyond what any other creature in the ocean is capable of achieving. In other words, just about anything might end up on the menu. The human brain, in contrast, is the undisputed learning master on the planet. Our cultures are infinitely more complex than orca cultures because the sheer volume and depth of memes we exchange is orders of magnitude greater. The flip side of this reality is that our big brains, advanced as they are, come with an array of complex shortcomings and are also expert at transmitting these shortcomings. One of the most perilous gene meme double whammies that humans possess is the notion of certainty. Our natures and our learned biases lead us to believe that we are right, whether or not we really are. This is the orca equivalent of learning the wrong way to hunt a great white shark, not a mistake any smart orca would copy. If orca cultures passed along memes that imperiled their members, they wouldn't be long for this world. Humans, on the other hand, pass on problematic memes like the notion of certainty on a daily basis. Rarely does this go well, but rarely does that stop us. The reason for our stubbornness goes deeper than we think. Neuroscience research is revealing that the state of not being certain is an extremely uncomfortable place for our brains to live. The greater the uncertainty, the worse the discomfort. A 2005 study conducted by psychologist Ming Su and his team found that even a small amount of ambiguity triggers increased activity in the amygdala, two deep brain structures that play a major role in our response to threats. Each amygdala is a cluster of nerve cells that sits under a corresponding temporal lobe on either side of the brain. Information pours into the amygdala from multiple sources. The amygdala filters through the information to determine its threat level significance and mobilizes a response.